Okay, so I think a lot of y'all put a good bit of thought into this to try to figure it out. I did like Jeremiah talking about the ceiling tiles being 4 foot, so there's a good way to get at it. And it took me a little bit, but I finally dug up the paper for this. I did measure the room and actually had this as a bonus question for doing wallpapering if we wallpaper this room to get to the number. Now, the overall shape of this room is not actually a complete square or rectangle because of the little cubby in the door, yes? Now it works out that that little spot there is about 6 foot wide. Now over here is about 2'8". This section here is about 19.8 feet. Coming across the top here is 25.8 feet. The front wall is 31.8 feet. And lastly, we have 22.6 feet. So if we add all these together, we would get the perimeter, because the perimeter is going all the way around, yes? Now, interestingly enough, is we could go through and add all of these together to get the perimeter of a rectangle, yes? What actually works out, interestingly enough, is what is, let's see here, get my, there it is, colors. What is the top length here? Okay. And if we add these directions together, what do we get? They will throw shapes like this in here that aren't regular. They are essentially a rectangle, but they have bits and pieces knocked out of it. But wait a minute, when we add all together, it's still a rectangle. Because we're not talking about area, because if we're talking about area, we would have to section it off and find the areas in individual chunks. But whenever we're talking about just the perimeter all the way around, really we can take 31.8 plus 31.8 plus 22.6 plus 22.6 right off the side, and we would get 102.8 feet. Yeah, and it's, they like, especially on the ACT, they like throwing in little chunks like that where it's not all square. But if we actually essentially, the way kind of I think about it, if we took this little divot out and threw it back out, popped it so it is a square, it's still the same distance. Now, if we're talking about area, we would have to section it off into the two groups and find the area that way. But with perimeter, we're just going all the way around. Any questions on this here?
Is it 102 or
10, let's see here. Yeah, let's see here. 31.8, 31.8. 6, 3.6, and then 25 or 22.6. 2, carry the 1, 2, 2 is 4, 5. Yeah, it should be 108.8. 108.8. Yep. Nice job. Now, we're not finishing this entire section today because we're going to start it today and we'll finish it up tomorrow. So until we get finished, let's put the Chromebooks away. Okay. Now, whenever we talk about perimeter, we're talking about a length and a width. The length is the measurement of the sides of a figure or a shape, usually the longest dimension, length. And then width is the measurement from side to side of a figure or shape. And a lot of the times, especially when we're talking about figures, length and width are really interchangeable most of the time with most figures. Because when we talk about the length and width or perimeter in most shapes, instances, we're just talking about these are the two going in a direction. Talking about a flat surface. And the perimeter is the measurement of the distance around a two-dimensional figure. If we trace it all the way out, that would be the perimeter. So if we look at this here, so this is in your note sheets for the first main shape. And if we want to find the perimeter of it, what are we going to do? Add them all up. So for this here, we would add 5, 5, 3, and 9 and get 22. And that would be the perimeter of this shape. So if we look at this triangle here, and you can fill it in on your note sheet because this one's the first one on the note sheet. We are given these three lengths. So we have a side length of 8, a side length of 15, and a side length of 19. Well, to find the perimeter, we would add them all up, which would be 42 inches. And that's all we'd have to do for this here. Now, when we look at the next one, we do have a pentagon. And it actually works out that this is going to be a regular pentagon because we know all the side lengths are the same. And it actually works out all the angles are actually congruent as well. So how can we go about finding the perimeter of this? We can say 9 times 5, which is 45 centimeters. Or we could have added 9 5 times and gotten 45 centimeters as well. So really, there's multiple ways that we could do it because there might be some shortcuts to get to the same answer. Like if we look at this one here. So what's one way we can find the perimeter? So 11 plus 11 and 5 plus 5, yes? How else could we have done this? 11 times 2 and 5 times 2. 11 times 2 plus, because, so 11 times 2 would be 22, 5 times 2 is 10, so it would be 32. This here would be 32. Is there another way that we can do this? Would this give us the same thing? I mean, at this point, we're just manipulating the numbers. But if one of these makes sense and you understand how to do it that way, do it that way. Understanding all of these is not crucially important. Find the length of a rectangle if its length is twice its width and the perimeter is 48. So when we look at a word problem like this here, really the first thing I would do, especially tackling any of these here, is kind of work through what it's saying. Find the length. So that's what we're finding, yes? So I'm wanting to know what L is. If its length is twice its width. So what did they say? The length is what? Twice the width, yes? So the value of the width is, well, we don't know what it is. We can just call it W, yes? But the length is going to be twice whatever that amount is. So for our figure, we can say we have a width and 2W, yes? Okay. Well, I know that this one down here is 2W, yes, because those are both the lengths. How about over here? This would be W, yes? Apparently if I hold, I get that. But what do we know about perimeter? It's all of these added to, yes? So how many do we have? We have 1, 2, 3, 4, 5, 6, yes? So 6W is equal to what? What do we do next? Divide 48 by 6, which is? And that makes the length what? So our dimensions of this here would be 8 by 16. That's not too bad, is it? I mean, this here is not, actually this here I think would be closer to something that we could see working out more in quote unquote real life. Because if we were trying to build a fence or build something that's rectangular and we want to know, we know that we have a certain amount of fencing and we want it to be at maximum length or maximum width and length, we could figure it out that way there. A triangle. Okay. Now, if I were working through this here on the ACT, because it says it's triangle, did they give us a triangle here? And on your worksheet, I think on page 148, do they give us a triangle there? Now, if they don't give me a picture of it, the first thing I'm going to do is draw one. It doesn't have to be accurate to the description. I just need a triangle. Since I talked about a triangle, I'm going to draw a triangle. A triangle has a perimeter of 22 centimeters. Okay, that's good to know. With a side that is 7 centimeters long. Okay, 7 centimeters long. The lengths of the remaining two sides have a ratio of 2 to 3. 2 to 3. What is the length in centimeters of the shorter side? So we have a ratio, yes? So for every 2 centimeters the one side has, how long is the other one? 3. Because for every 2 the one has, the other one has 3. So for one of these sides, we can call it what? 2. And the other one be 3x. Because we're going to call it 2x and 3x. Because do I know how many of each I have? No, I just know the values for those two sides are 2, 2, 3. But what do we know that all 3 of these do add up to be? When we say 2x plus 3x plus 7 is? Divide both sides by and I have a feeling on the ACT, 3 is going to be one of your answer choices. Is it the correct answer? What does it want? Well, 3 times 2 is, and 3 times 3 is. So the shortest side is actually what? So they'll do that every now and then, where if it's asking you to have to plug something back in, they'll make whatever you solve for be the answer and have it see if you pick yet. Any questions on this here? All right. Let's Let me go to the next page. This is the last one we're going to look at for today, because I'm going to give you time to work on the exit ticket or entrance ticket if you haven't finished those from the other days. What we want to do is find the perimeter of this here. And kind of as I talked about or mentioned earlier, even though we don't know, and sometimes on the ACT, it will give you all these little links and ask you to figure out what they are so that you can find the perimeter. But still, the overall distance is still 28. And still, the overall width is still going to be 18. So even though it has these little bits cut out, if it's just asking for perimeter, well, we could do 2 times 18 plus 2 times 28. And we could plug that into a calculator and solve. And get and we get 92. So before we finish, one of the things I do want to say is a lot of these here aren't that bad. Some of the ones that are not always, but a lot of the time, some of the easier math problems are the big word problems. Or some of the ones that they throw in there just to see if you're willing to be able to read it or want to read it and figure out what it's saying. One of the ones that they love throwing on there, we'll get to them eventually, is they talk about directional, and if it is on the, I think it's, the correct term is kind of cardinal directions. So we're talking north, south, east, west. We're going one of the 4 directions. Because it gives it to us. Timmy starts at his house and goes 6 miles north and then travels 16 miles west. How far is Timmy from his house? That is completely Pythagorean theorem. Because if we're talking about traveling north, south, and then east or west, it's actually Pythagorean theorem. Because I'll draw it out here, north, west. How far is he back from where he started? So, and we'll get to those eventually, but for this here, we're